Hello and welcome to this very special episode of the Autocar Professional Dialogue. Our guest in this episode is someone who designed his first car at the age of 19 and raced it a year or two later, who grew up to be the technical director of the McLaren F1 team and was the man behind the road car from McLaren, and 7 years ago turned entrepreneur by setting up his own firm. We are talking to Professor Gordon Murray. Professor Murray, thank you very much for talking to us.
It's a pleasure.
First, as an engineer, what comes to your mind when you're here in India?
Well, first of all, I love India. I love everything here, the culture and everything. But as an engineer, what comes across to me is the difference in problems we have around the world. You know, the basic problems are the same, but the difference in applications of solving problems is just so different. And no better demonstration than here in India. You know, for example, the traffic flow issues, we have a massive concentration of two-wheelers I haven't seen anywhere else on the planet yet. And that brings a set of urban planning issues that we don't see in Europe. I think too, I'd like to have a crack at the problem over here from a congestion point of view, because the vehicle footprints aren't what you would expect. You know, you've got the little tuk-tuks, which are fine because the density of occupants is very good with those, but there's a lot of other cars where the occupant density is not very good for the problems you have. You know, so I'd like to look at it rather from a car design point of view. I'd quite like to look at the Indian congestion problem from a urban traffic flow point of view.
So do you already have a concept in mind for India or markets like India?
Obviously you need smaller footprint cars, you know, you really do. It's the same. I mean, we have a ridiculous situation in London where people insist on driving great big 4x4s. You don't have that issue here, but in London, it's a cultural thing, you know, because if you go to Paris, everybody's in small cars. Everybody's driving smarts, they're on scooters. They're in old Renault Twingos, anything small. And if a big 4x4 comes through, people stop and look at it. You know, in London, it's the opposite way around. You know, 1 in 100 cars is a smart. The rest of them are these great big things. So I think it's a cultural issue as well. You know,
and that culture is also gaining acceptance here. I mean, I'm talking about 4x4s, SUVs. I mean, there are a lot of them. In fact, that is the only segment that saw growth, that's been witnessing growth in the otherwise down automobile market. So perhaps we'll have a similar situation in many metropolitans here as well.
Well, I hope not. I think common sense and legislation will probably overtake that culture.
So talking about solutions for markets like India, do you feel that the T25 or the T27 could also be suitable for India?
Absolutely. Urban areas, definitely, because it's not just the footprint of the car. It's the fuel economy and emissions, and the T25 has 4-star Euro NCAP crash test. So it's a safe small package, and that's exactly what you want for an urban environment. You know, you're not doing the damage, you're not causing the congestion because you've got a smaller footprint. It's 3 people in a tiny little motor car. Yeah, I would say. So
I mean, you won't be surprised if Yamaha do you think Yamaha would have India in its mind?
No, I think at the moment Yamaha are concentrating on Europe. But they do have future aspirations, I'm sure. I think they want to see how it goes in Europe. The motive is designed absolutely primarily for Europe. And there are some export opportunities or local manufacture opportunities in the future. But it's a European car.
But while from a drivability perspective, from an emissions perspective, it may be a right product, but it may not be so from a price perspective.
Exactly. I mean, that's another issue.
Yes.
That's another issue. The motive is designed for the sort of, let's say, upper commuter. It'll sit comfortably in the smart Toyota IQ segment, and that's expensive.
So would you like to have a version or a derivative from the T25, which you would perhaps be tailor-made for emerging markets?
Yeah, I mean, the T25 in its base form would be perfect because it would be a very low-cost motor car, way below the segment the motive is designed for.
And how about the T27?
27 is really just an electric T25. So, yeah.
And because electric mobility is also being propagated in a big way in China, and India is also expressed its intent of promoting electric vehicles.
Yeah, I mean, EV only makes sense with the current battery technology, which is very expensive, and very heavy from an energy density point of view. It really only makes sense for small, light, efficient city cars.
And your iStream concept, which also again is a very radical way of manufacturing. And surprising that OEMs are not falling on top, falling for it
they are
yet.
now. They are. They've taken a while, but they are. I mean, before the coincidence we had in 2008 of the energy crisis with oil prices going up and the financial collapse, before that we thought we wouldn't ever see an OE with iStream. It's just too disruptive. You know, it doesn't tick any box for them really. They've invested an enormous amount of money in stamped metal, and they have an enormous amount of knowledge invested in stamped metal. And iStream doesn't use any of that stuff. It's incredibly disruptive. So we didn't think there'd be an interest at all. But I think the coincidence we saw in 2008, I mean, we've been very lucky with the timing. The coincidence brought a lot of OEs to our door, and we're currently working with 4. On 4 of them on 6 motor cars, actually.
Oh.
Yeah.
So you're talking to 4 OEMs?
Yeah. We're actually working on product for them.
Okay.
And I think it's because they've seen a need to change. It's lots of reasons if you think about it. You know, there's an enormous amount of uncertainty with future powertrains. There's a need to reduce weight for efficiency. There's a limit to how much weight you can reduce with steel. Anything else you try and reduce weight with costs more money. iStream, you spend less money and save weight, so it's attractive. There's a massive change in the way the young people are looking at car ownership, purchasing models, ownership models, servicing models. And with all that uncertainty, which powertrain's going to float to the top? The old model of investing millions or even billions in one platform for 10 years with a couple of facelifts and making hopefully 200,000 cars a year and making a return on investment in year 6 or year 7, it just doesn't work anymore.
So what would be the business model like? Suppose if I were an OEM, how much would I have to spend compared, suppose for a capacity of about 200,000 annually, compared to the conventional manufacturing process? How much would I have to spend, and how quickly can I get my return on it?
The savings with iStream come in different sectors. The first sector is capital investment. And capital investment we can generally reduce by about 80%. It varies, but it's generally about 80%. The best case we've seen is an 85% reduction in CapEx. Then the secondary saving comes in manufacturing energy. So the factory is much smaller. The frame plant is only about 17 to 20% the size of a stamped steel plant.
Okay.
So we use 60% less energy. That's gas, electricity, welding, all that stuff. So there's a secondary saving in the manufacturing of the motor car. And then, of course, the real saving is for the end user. When you pass on a car that's stronger and lighter, you're using less fuel.
And in terms of the interest expressed by OEMs, and you talk, any of them from India or from this region?
We're actually working. One of our customers is from this region, but the product we're working on is not for this region at the moment. We are actually working on another product for an OE customer that could very well come to India, but unfortunately, because it's our customer's choice when they say they want to launch the car, what they say about the car. We can only talk about actual vehicles that are in the public domain, and the current one is Yamaha.
So, and the future one also, one of the two, I mean, India could see a car built in that iStream manufacturing process.
Definitely.
Talking about India, what is your opinion on the engineering capabilities of, I mean, India is being made more popular with the phrase frugal engineering. And what is your opinion on that, and especially on projects like the Nano, for example?
Well, I think the one company that's changing all that is Tata. I think it's just amazing. If you look at the last 10 years with Tata and go from what Tata stood for, not from a truck point of view, commercial vehicles, I mean, it's hugely successful for years, but from a passenger car point of view, if you see the turnaround the Tata Group have produced with JLR in England it's phenomenal. I mean, that's a success story I thought I would never see in England. I mean, that is just phenomenal. And then the second one is to have the foresight, let's say, to try and make the Nano as a complete rethink on low cost. So, you know, if you look at what Tata have done at two exceptional extremes, JLR, it's difficult to think of another brand they could have picked, a prestigious brand that needed saving. You know, BMW didn't need saving, Mercedes-Benz didn't need saving. Probably the only one in the world was JLR. And Tata have done a massive turnaround on that, which, you know, is phenomenal. I can't think of another company that could have done it, actually. And then you go right to the other end of the scale and you try and build a car for £1,000. I know it didn't quite work out at £1,000, but the vision to do that, you know, in some cases the vision is more important than the actual result.
Exactly.
You know? I mean, you could point a finger at me and say, well, you built 100 cars for very rich people with the McLaren F1. Absolutely true. But it's inspired a lot of people, I think, I hope, from its engineering and from its vision. And you could say the same thing about the Nano. I'm sure all the other car manufacturers, when that was announced, got a big fright and started concentrating a lot more on reducing the cost to the end customer. So it's inspirational, but at both ends of the scale. I can't think of another car company that's ever done that.
Talking about F1, you have translated many of the technologies found in F1 into your manufacturing and in your technology in your cars. Do you think there are more which could be kind of brought and implemented into road-going cars? And if yes, what would they be?
I think there are technologies in Formula One that influence road-going cars. I mean, the obvious ones are fuels and lubricants, tyre design, basic advances in engines and clutch systems and electronic control systems. Those are all the obvious ones. The aerodynamics, probably not, to be honest. I mean, Formula One aerodynamics are so specific for downforce that I can't see anything applicable with that. The difficult one has been materials. That's the one that, you know, the McLaren F1 wasn't a clever car at all. All that did was take handmade Formula One technology and build a very expensive road car with the same technology. That's not clever. That's just transferring technology from one area to another area. iStream, on the other hand, is very clever because that takes Formula One technology and reduces it to a cycle production time and a production cost that's affordable by anybody here, you know. And that's the trick with iStream. So it doesn't use Formula One materials, it uses Formula One technology. So there's a big transfer there. So you have to be, when you're talking about Formula One technology transferring to road cars, you have to be quite careful about what you mean by that, you know, because sometimes it's inspirational only, sometimes it's functional, sometimes it's a systems crossover like iStream, but not using the materials. Because carbon fiber, you know, there's this great thing in the car industry now, carbon fiber is going to become cheap as chips one day. It's not, you know. It's still a very expensive material. It takes 5 months to make carbon fiber, and it's very expensive. You can use it for small sections like BMW are doing, small bits of the car, but to make a complete carbon fiber road car would never be affordable for the everyday motorist like you and me.
Talking about iStream, what is the kind of optimum production level for which the iStream would be, iStream technology would be ideal?
From a volume point of view, it works pretty well down to about 15 or 20,000. Below that, actually, you can demechanize iStream. The manufacturing process for the body shell, if you like, the monocoque, is normally about 95% automated, like a stamped steel car is with spot welding. It's pretty well automated. If you de-automated that, you could go down below 15,000. But generally speaking, that's the low end, and the top end's probably 150, 160,000 units a year.
Annually?
Per year, yeah. So the sweet spot's around 80,000, 100,000 units a year.
And could you give us a rough idea about the application that some of your new projects, you said 7 new projects are at work, multiple powertrains. I understand you've got non-disclosure agreements with your clients, but could you give us a broad idea about what kind of applications, what's the range of applications we could see?
It's incredibly broad. I mean, at the small end, the one that's public is the smallest end, if you like, a two-seater city car. It doesn't get much smaller than that. And at the other end of the scale, we're working on a 3.5-ton off-road truck, which is iStream.
iStream.
Yeah. And everything in between. It's not, 3 years ago we were in great danger of becoming known as the city car company because that's what we started with 25 and 27. But it couldn't be further from the truth. We're working on a whole range of vehicles, different sizes.
All right. And you are a big, strong proponent of lightweighting technologies. Could you tell us what are the new ways by which the envelope can be pushed further in the area of lightweighting?
Well, at the moment, the big problem in the automotive industry, people are either focusing on tiny parts of the car, which don't actually give you a step change. It's changing, making a carbon fiber boot or bonnet or door skin, isn't going to get the job done. It really isn't.
Whereas it adds to the cost.
And it's much more expensive. High pressure magnesium castings for the instrument panel, massively expensive. Boron steels, that sort of stuff. Aluminium even, very, very expensive. I think the only way you're going to make a step change, a big change, is to do something like we're doing, which is very disruptive, where you take the whole structure of the motor car, chuck out the whole lot, and start again. And that's iStream.
So I would assume that there will be many more such concepts in the focused with the objective of reducing weight at work in your laboratories, right?
Yeah, I mean, we don't stop. I mean, we're already working on, everything's patented and trademarked and all the rest of it. But the real protection is we're already working on iStream 1.5, iStream 2, and iStream 3. Oh. So just got to keep going, and that'll be different materials using the same technology.
And I would like to ask you one question on the IC engine. From what we also saw today, it seems that the IC engine is here to stay for at least for the foreseeable future. Yep. But in terms of the enhancing the efficiency, and you've mentioned that less than 30% of the energy of the IC engine is actually utilized.
Yeah.
Are you working on any new ways by which you can increase that efficiency level of IC engine? What are the ways?
We have a powertrain department, and we've worked on and are working on hybrids, petrol, diesel. We built a fuel cell, a hydrogen fuel cell for one customer. But we're not really engine people. We have a powertrain department as a service industry to iStream, which is our core product, if you like. But I think there are some advances still to come, and probably on downsized engines with forced induction. So, combining turbocharging and supercharging and variable turbocharging and stuff like that. There may be some big-ish steps, but there's not one major step. It'll be lots of small stuff. The problem is, it's the law of diminishing returns again, a bit like materials and the car structure. It's more expensive. Every time you have variable valve timing, twin spark plugs, whatever it is, 5 valves per cylinder, 6 valves, it's more expensive every single time. So it's definitely the law of diminishing returns. Without a doubt, the last big frontier in car design is weight. That's the one where we still have a chance to make a big step forward.
Big step. Yeah. When can we expect the next big step from Gordon Murray design?
Well, I suppose the next big step is to actually get one of our cars into production so people can experience. It's not just about fuel consumption and emissions, it's about driving pleasure. Because we're all still motorists, we all still like driving the car, and a very rigid, lightweight car with independent suspension is going to be much more fun to drive at any speed.
And Professor Murray, we are sitting here in Chennai, and India is known as a very rich talent pool of engineers. Have you looked at tapping this talent pool in India in some way for your operations?
Yeah, we have. I think I'm right in saying we have 3 or 4 people in our company. We've only 65 people, I think we are currently. And we've got 3 or 4 people that have come out of India working in our company at the moment.
Right.
Yeah.
At a later stage, maybe over the years, can we expect to see a kind of a satellite plant of government design in
yes, it
in
could
India?
happen. Funnily enough, we're in the process of working right now with the Brazilian government to do a technology center. It's an incentive the Brazilian government have at the moment to do a technology center using my name
I see.
with a Rio University.
Oh.
So it's absolutely a possibility, yeah.
Okay. Have you initiated any talks in India yet, or it's
No,
that's
not
something
yet.
that-
No, we're so busy working. It's difficult to do the peripheral stuff. You know.
But Professor Murray, always pleasure talking to you, and thank you so much for sparing your time. But I'm not letting you go without a sketch from you. Suppose if you were to design a car for an emerging market like India, what could it look like? If you could just prepare a sketch for us, please.